All right, you guys. So right now for number one, we have that point P has coordinates -3, 2, and point Q has coordinates 15, -8. They tell us that point M is the important word midpoint of PQ. And so for part A, we need to find the coordinates of M. Now guys, for this whole paper solution, the method that I like to show is that once you identify buzzwords, which is like keywords, if you want to think about it this way, like very important words, this allows you to find the correct procedure and oftentimes the correct formula to use. All right. So let's always focus on the buzzwords, always focus on the keywords, and this is a big hint for which procedure or formula to use. So in this case, the big buzzword here is midpoint. So what is a midpoint? The midpoint, quite literally, is the middle between 2 points. So for example, here you have A and here you have B, okay? The midpoint is going to be right around here. It's right in the middle. So if this whole distance is, I don't know, 6, that means here you have, from here to here you have 3, from here to here you have another 3. Okay, so that is what a midpoint is. And for finding the coordinates of M of the midpoint, there is a formula. And so the day of the test, you guys, you will be walking in with the formula booklet. And so why do I talk so much about knowing the buzzwords well and the keywords well? Because once you know the keywords well and the buzzwords well, a lot of times they're in your formula booklet. Guys, the day of the test, you're walking in with like, 2 years of experience in this thing called IB, 2 hours of sleep, a lot of motivation to do well, a calculator. Well, for paper one, you don't have a calculator. Um, a formal booklet, a pen and pencil. See? And so the formal booklet is a tool that you can use the day of the test. So get familiar with it. So once you identify midpoint, you look for midpoint over here, and eventually you're gonna find this. So on the one hand, you have midpoint for x, y, and z, okay, which is a graph that looks like this. So here you have x, y, and z, all right? And for the other formula of the midpoint is quite simply for just x and y, okay? So this is the more classic, the more friendly, and this is a formula we're going to be using. So the midpoint formula for part A is your midpoint equals x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And just so that we're all on the same page, this right here is really just a set of points. Okay, it's an x comma y. Your midpoint is a set of points. All right, so this is just an x comma y. And what does the little one do? What does the little 2 do? This is just your first point and your second point. So for example, your first point is x1 with y1. Your second point is x2 with y2. Ah, that makes a little bit more sense. So x1 is -3, y1 is 2, x2 is 15, and y2 is -8. And now that we understand all of that context, suddenly this becomes way more friendly. And I go ahead and plug into the midpoint formula. So for this first one, I end up with x1 we said was -3 plus x2 is 15 divided by 2, comma, y1 we said was 2 plus y2 we said was -8. So plus minus 8 divided by 2. So the plus minus 8 just ends up as -8. And my midpoint ends up being, on the one hand, I have 12 divided by 2. On the other one, I have -6 divided by 2. So that means that my midpoint officially is now going to be 6 comma -3. So that is for part A. Later on, they tell us that line L is perpendicular to PQ and passes through M. So which is the keyword here, you guys? The keyword here is perpendicular. Now, for perpendicular, I don't think it's in a formal booklet. No, it's not. So this is something you have to sort of learn by heart, okay? Perpendicular makes reference to slopes, okay? And so the two types of slopes that you can encounter for part B, okay? The two slopes that you can encounter, because for part B they ask, find the gradient of L, see? So L, we know is perpendicular and passes through M, see? So L is a line, And so for getting the equation of a line, your main tool, and this is here in your formal booklet, so equation of a line, equations of a straight line, I think it was, yeah. So here are your three equations of a straight line, see? You use these for different purposes or whatever, okay? But my suggestion and what I want you to really put into your brain is that for creating lines or for creating equations of a straight line, the one you're going to pretty much always use is this one. This one is called point slope formula. Now let's take a moment, let's look at it, let's understand what it's asking for. And so in order to create the equation of a straight line, all you need are this, this, and this. Okay, if you plug in those three things, you're good to go. So y1 and x1 is a set of points. So if you have a point, you're halfway there. And if you have m, you're good to go. Now what is m? M is the gradient. What is gradient? Gradient is slope. Okay, so the moment you have a point and the moment you have a gradient, you can use this equation here and you create the equation of your line. Now, back to reality. In part B, they tell us that line L is perpendicular, so this is a big hint for M, okay? Like your slope, so slope M. I know there's two M's here, so I'm going to put slope M. And they tell you that it passes through midpoint M. And so midpoint M we said was 6, negative 3. So for the point slope formula, which uses y minus y1 equals m times x minus x1, I already have my y1 and my x1 because we're going to be using the midpoint from part A. But for the slope, I still need to figure it out. And so the keyword of slope is perpendicular, okay? So I'm going to talk a little bit about that right now. So your slopes, there are two types, okay? You have, like special types, right? So you have parallel slopes and you have perpendicular slopes. The hardcore math definition that I'm going to give you is that when your slopes are parallel, the slope of the first equals the slope of the second. That is why I'm putting 1 and 2, okay? While for perpendicular, the slope of the first times the slope of the second equals negative 1. Now, how does it look visually? Parallel lines look something like this, okay? So they travel on forever and they never touch each other because they have the same slope, because they are always growing at the same rate, and so they will never touch each other. If they were growing slightly at a different rate, eventually they would touch each other, okay? But in this case, parallel lines have the exact same slope. For part B, they tell us we have perpendicular slopes. And so perpendicular slopes, how does it look like? It looks a little bit like this. Okay, it's two lines that cross, but they cross in a way, they intersect in a way that you have 90 degrees all around it, okay? And so they are perfectly sort of like, kind of like mirrored, okay? Just intuitively have that idea. They're kind of mirrored, they're kind of like perfectly opposite and stuff like that. And so, it's not exactly that, but intuitively I want you to have that idea. Perpendicular lines look like this, okay? And 90 degrees show up all around it, see? And so the hardcore definition is that the slope of the first times the slope of the second equals negative 1. Now, what a lot of you guys have probably been taught is that for perpendicular slopes, m1 is going to equal, if I get m1 alone, right? So you divide by m2 to both sides, right? So that means that m1 is equal to negative 1 times 1 over m2. And so this is what you might have heard as the negative reciprocal. So negative because you have a negative 1, and reciprocal because you're flipping the slope. So if your slope is, I don't know, 7, for example, if the slope of your line 1 is 7, and you know it's perpendicular, the slope of line 2 is negative 1 over 7. If line 1 is negative 4, then the negative reciprocal is that you flip it, and you put a negative, right? So it's negative 1 over 4. It's just 1 over 4. And another example, let's say you have 1/2, so the perpendicular of this would be negative 2, because you flip it and you put a negative. All right, so that was a pretty long explanation, but I'm sure someone out there needed it, so this one's for you, okay? Yeah. So perpendicular slopes is the negative reciprocal, and so the slope that I know, actually you don't know a slope. You first need to find the slope. So this got even more interesting, see? And so the gradient of L, which is what they're asking you to find, is perpendicular to PQ. And so that means if I find the slope of PQ, I just need to do the negative reciprocal, and that gives me the slope of line L. So what is the slope of PQ? Well, the formula for slope is right here. It's y2 minus y1 divided by x2 minus x1. So just to be a lot more organized in this approach, let me erase here a little bit. So first, we're going to find the slope of PQ. So slope PQ is, so slope PQ, the formula first is m equals y2 minus y1 divided by x2 minus x1. Some of you might have been taught that the slope is rise over run. And here it makes sense how the formula looks, because your y values, which are vertical for rising, are on top. So that's why rise is on top. And for running in horizontal, you have your x values. So that's why y is on top and x is on the bottom. Rise over run, okay? Anyways, so the slope PQ, well, you have 2 points, right? So you have the point P, which is negative 3, comma 2, and you have the point Q, which is 15, comma negative 8. So if you use the gradient formula here for the slope, you end up with m of this guy, so m PQ, okay? Just to be more organized, so your m of PQ is going to be y2, which is this guy here. So this is y2, this is x2, this is x1, this is y1. This is going to be y2, which is negative 8, minus y1, which is 2, divided by x2, which is 15, minus x1, which is negative 3. So on the bottom, you have negative negative. So up top, it's negative 10. On the bottom, you end up with 15 plus 3. So that means the slope is going to be negative 10 over 18. Okay? And if you want to get fancy, you would simplify this a little bit. Because they're both even, you can divide both by 2. You end up with 5 over 9. Okay? So basically, the slope of PQ, okay, is 5 over 9. And this is enough for you to say that the slope of L has to be the negative reciprocal. So it's going to be negative 9 over 5. All right? And I just noticed, my bad, you guys, but I'm going to leave it in the video because we all make mistakes. There was a negative right here. And I forgot to put it here. See? So we all make mistakes. We all need to double check sometimes. This negative should have stayed here. So that means that over here I put negative 5 for slope of PQ. So that means that the negative reciprocal ends up being negative 9 over 5. So it's just positive 9 over 5. So my gradient, finally for part B, my gradient is 9 over 5. And last but not least, you need C. Hence, write down the equation of L. Now, I told you guys way earlier, I did get a little bit ahead of myself, but for writing down the equation, you need the best, in my opinion, is the point slope form. See? And so the point slope form, what it needs is a set of points and a slope. And so the set of points, I already have it, because as I mentioned earlier, the set of points we're going to be using is the midpoint. And the slope you're going to be using is the one we just found, right? And so for part C, you just need to plug all of that in. So it ends up being y minus negative 3, because of this guy here, right? Equals your slope, because of m, so 9 over 5, times x minus your your x1, right? Minus 6. So y plus 3 equals 9 over 5x minus 9 times 6 divided by 5. So y plus 3 equals 9 over 5x minus quick maths gives me 4554 over 5. All right, and technically, from here, you're like good enough, okay? From here, you're fine. But just to show like the whole process and just to get full credit or whatever, technically from here, it's already good enough, okay? I'm just looking at the answer key. I'm just gonna be transparent with you guys. You can leave your answer as this, okay? Which is like pretty much the first step of using the point slope form. So apparently that's good enough, but I'm a guy that would rather play it safe and like go all the way. So if we go ahead and go all the way, you want to get this guy alone. See, you want to get y alone. You want to reach y equals mx plus b. And so to reach y equals mx plus b, you need to get y alone, so you can do minus 3 to both sides. So that means you end up with y equals 9 over 5x minus 54 over 5 minus 3. So that means you have y equals 9 over 5x minus 54 over 5 minus, and here you need to amplify, right? So you amplify by 5. So you end up with a 3 that is times 5 on the top and on the bottom. This allows you to combine the fractions. So 9 over 5x minus 54 minus 15 divided by 5. Okay, so y equals 9 over 5x minus 69 over 5. Okay? And so as long as you show all your process, they definitely give you the point up here. I'm the kind of guy that like gets stressed out and would rather just go all the way, so might as well show you how to reach the form y equals mx plus b for any future exercise, okay? Anyways, that was a little bit of a long explanation, but I'm sure someone needed it, so here it is. I hope it helped, and I'll see you around.